Hello, respected learners. So, today we are going to discuss pointers in C. So, basically, in C, there will be three kind of pointers. Uh, 1.1, which is associated with the normal variable, another pointers which is associated with the array, and third category of pointer is which is associated with the structures. So, we will discuss one by one in the forthcoming lecture. So, today we are going to discuss pointers associated with the ordinary variables or the normal variables. So, as far as declaration of pointers is concerned, so it will be declared like first data type, then asterisk. So sometimes it is called dereferencing operator or indirection operator, and then the name of variable. So this name of variable is obviously it is an identifier. So this indicates that whether we are trying to use or declare a variable whose data type is as per the requirement of the user. So here, like one example I have taken, that suppose here we are trying to declare a integer pointer variable. So here the data type is int, then asterisk, and then the name of variable x. So here x is an identifier. So although the complete declaration of any variable in C is, so first it will be declared with the storage class, and by default storage class is always automatic. So we'll discuss in the uh, forthcoming sessions. So but till if here we are not specifying any storage class, so it will be automatic. Then name or data type, so here it is integer, and then asterisk or dereferencing operator, and then name of the variable x. And suppose, so actually we will have to think why pointers are required in C. So pointer is a variable which is used to hold the memory location of some other variable. And let's say for example we have another variable y which is having obviously the same data type, that is an int. So here y is an integer type variable, and let initially its value is 5. So if we are saying that pointer variable is used to hold the memory location of some other variable, so that we are writing one statement in C. Here x is assigned with the address of y. So it can be written as x is assigned with ampersand y. So here ampersand or address operator is there. So let me try to understand what is its meaning and how it looks like. So suppose here we are having two variables x and y, and after these declaration, suppose in the memory x, the memory location of x is 100 and the memory location of y is 200. So here we have specified, so we are only supposing it. Now so after writing this statement, y is assigned with 5, so the value of y here is 5. So that means in the memory 5 is stored at memory location 200. Now what second expression says x is assigned with ampersand y. So here the value of x is ampersand y. So the memory location of y is 200. So the value of x becomes 200. And suppose the memory location of x is 100, although here we are not going to use the memory location of 100. Let's suppose we are trying to print few statements in C. So suppose here we are trying to write printf percentage d y. So what the output will be, what will be the output for this statement? So it is a normal statement in C, so we will get the output as 5 because the value of y is 5. Now if we are talking about the second statement that we have written, that is x printf percentage d asterisk x. So asterisk means what here? So here we are trying to dereference the variable x, and the variable x will hold the memory location of y. So the meaning of asterisk x is, so we can understand that value at whatever the value of x, so that means value at 200. So value at 200 is, so this is the memory location 200, so value at 200 is 5. So the output corresponding to this statement where we are writing percentage d asterisk x, so it will again give the same output, that is 5. So here we can see it. Now if we are talking about a third statement that we have written, so it simply says that if suppose we are trying to print the value of x, so here the value of x is 200, which is actually the memory location. So to print the memory location in C, we will use specifier as percentage u, because it will be always a positive number. So whenever we are printing this statement, then we will get the output as 200, because the value of x is 200, right? So if you are trying to print the normal value of x, then it is a 200. If you want to print the asterisk x, that is value at x. So value at x means value at 200. So value at 200 is 5. So we will get the original value. So basically we'll see why we are using these pointers, because we can print 5 already, which is our first statement. So why we are trying to print the same value here using asterisk operator? So the reason is, it will be better explained when we will discuss the concept of call by reference function in the next session, where we will see that in the call by reference function, from the actual parameter, actually we will pass the memory location of the actual parameter into the formal parameter, but in call by value function we will pass the value of the formal actual parameter into the formal parameter. So in the similar way, if we are talking about the pointers associated with either character or float, so here we will have to only change the data type of the variables, and the rest remains same. Only we will have to taking care of it, although pointer is a variable that is a holding the memory location, so it will be always hold the memory location as integral value. But how compiler will know that whether variable on the memory location holding for some variable, it is either character or float or integer? So to match that, that's why every time the data type of both variable, that is normal variable and pointer variable, it must be the same. Am I clear? So obviously pointer is not only the single pointer where we are using only asterisk x. So in the next session we are also try to address that if we have pointer which is associated with the uh, double pointer, or the pointers which is in the form of triple pointer and n pointers. So we'll see what is its use if we are going to be with the some higher pointer values, right? So in the next session we'll see all these things. So thanks for today.